Hello, sixth graders. It's lesson 6, writing expressions where letters stand for numbers. So we have two big learning goals today. We want to be able to use an expression that represents a situation and write an expression with a variable. Here we go. Make sure you have today's note page. Our first problem is about something that maybe you have experience with, or somebody in your family, or you've seen a kid do this. Lynn set up a lemonade stand. Someday it'll be summer, and you'll see lemonade stands again. She sells the lemonade for 50 cents per cup. Here is her first cup of lemonade. It costs 50 cents. There's a table down below that we need to fill in. On the top it says lemonade sold, 1 cup. Well, I just showed you that. The money that Lynn collected was 50 cents. And right above that, I'm going to write a multiplication problem. 1 times 50 cents. Because I can see 50 cents one time. Lynn is getting pretty good at this, and now Lynn has sold 2 cups. There they are. Each cup is 50 cents. So if she sells both of those together, that'll make $1. And take a look at the multiplication sentence. Now it's 2 times 50 cents. The price of the lemonade does not change. Each cup is 50 cents. But what is changing is the number in front, which refers to how many cups Lynn has sold. All right. Let's see now. Wow, Lynn is getting really good at this. Lynn has sold 12 cups of lemonade. Right, I already have 2, 3, 4, 5, 6, 7, 8, 9. I ran out of space. Lynn sold 12 cups and each one cost 50 cents. So we can add 50 cents plus 50 cents plus 50 cents plus 50 cents. Or we can say that Lynn sold 50-cent cups 12 times. 12 times 50 cents. And when you put that in your calculator, let's grab this one, right, clear this out. Right, should have just put them right next to each other here. There we go. Yep, there we go. All right, 12 cents, or 12 cups of 50 cents is $6. All right, getting pretty good. But what if Lynn sells 183 cups? Again, the number in front is what it keeps on changing. First it was 1 times, 2 times, 12 times. So this time it's going to be 183 times 50 cents. 91.5. And if you remember, money always has 2 digits, so don't forget to add this extra 0. So we have a definite pattern happening here. It's however many cups there are times 50 cents. So Lynn can predict how much money they will make if they say the cups times 50 cents. So we're going to write that as C times 50 cents. And then you might remember from the last week and a half that we will put the 50 cents in front. This is our coefficient, 0.5. Right? And then we put the C behind and we smush them together. This is an expression. 0.5C is an expression. It's a number and a variable with an operation. In this case, it was multiplication. We can use that expression to help us solve further problems, like this one. How many cups did she sell if she collected $127.50? So what's different about this problem is they're not giving us the cups, they're giving us the money. So I want you to draw an extra row, 2 extra rows, so an extra column, and $127.50 goes on the top. Oh, no, it doesn't go on the top. It goes on the bottom. $127.50 because the money goes on the bottom. So we're going to take this equation that we just found, the expression, and set it as an equation. So we're going to say, if we use the rule 0.5 times C, that'll give us the money that she makes. And they told us how much money she makes, $127.50. We've been practicing a lot. We know that we can just divide by the number in front by the coefficient, and that will tell us what the variable equals. So we're going to say C equals $127.50 divided by 0.5, 0 and 5 tenths. 127.50 divided by 0 and 5 tenths. 255. That is a lot of cups of lemonade. But it should be a lot of cups because $127.50 is a lot of money. All right, let's try another problem. can get rid of my calculator for just a moment. The next problem is about Elena. There she is. Hi. Elena is 59 inches tall. And some other people are taller than Elena, and you can see that I wrote the word bigger there. They're not telling us how tall Andre is, but they're telling us that Andre is 4 inches taller. He's not 4 inches, he's 4 inches taller than Elena. So if I wanted to know how tall Andre was, I would have to take Elena's height, which was 59, and 4 inches taller. Remember how he said that's bigger? Then that's plus 4 more inches. So the expression is 59 plus 4, and I can do that without a calculator. 59 plus 4 is 63 inches. Andre is 63 inches tall. Then there's Lynn. Lynn's here with the heart shirt. Lynn is 6.5 inches taller than Elena. So we're going to start with Elena's height plus 6 5/10. All right, it looks like we might need to bring this back. Plus 6 5/10. Go, calculator. All right, Elena's height, 59, plus 6 5/10, gets us to 65.5 inches tall. And then they're telling us that Noah is D inches taller. They're not telling us how much taller Noah is, but they're saying, when you know it, we're going to plus that amount. So for Noah, where it says D, we're going to follow the pattern. Each problem started with 59 plus. 59 plus. For Noah, we're going to do the same thing. 59 plus, but because we don't know how much taller, we're going to say D. We're being asked now to figure out if Noah is 64 3/4 inches tall, how much taller is he than Elena? So we're going to figure out this D number that was for taller. We're going to use the expression that we just got, 59 plus D. When we add Elena's height plus the taller, we will get, what was his name? Noah's height. And they just told us Noah is 64 3/4 inches tall. Again, we know we need to use the opposite operation, the inverse. So to solve for D, we're going to take 64 3/4 and subtract 59. 64 3/4 subtract 59. Oh, try again. We lost something. 64 3/4 subtract 59. Oof, 23/4. I'm not really sure what that means. So I'm going to press second and convert that into a mixed number. 5 3/4. That number makes a lot more sense to me. That means that Noah is 5 3/4 inches taller. He's not 5 3/4 inches. He's 5 3/4 inches taller than Elena. These problems will get easier as you practice them. You will be doing more of them with me in small group.